Hello everyone, True Zero Emissions here. So I'm going to start making more videos talking about a process that I'm still learning to understand, and I've been aware of this for a long time. I'm always trying to make the perfect video, have the perfect understanding. How can I think about this? How can I explain this? It's free energy, right? Richard Feynman taught us, Nobel Prize winner and 37-year professor at Caltech, Pasadena, which is connected to NASA and JPL, right? Richard Feynman's a brilliant physicist. Taught us that there's megawatts of energy, right, in a cubic centimeter of space. Right here in the actual space between my fingers, there's all this potential energy, right? When we look into deeper to where energy comes from and the origins of energy and how energy moves and how it works, there's like an endless mystery. It just keeps getting deeper. So on the surface, it looks like we know everything. Like we talk about the laws of physics and things, right? Then we look deeper and we find out those laws of physics are just theories that are always being updated. So a law, as it applies to physics and science, is really just a theory. It's a conclusion that is subject to change. It's not fixed, right? So Richard Feynman said that we actually don't know where energy comes from. I'm sorry. I'm getting notifications on my phone and I'm trying to read them while I talk to you. Big mistake. Richard Feynman said that we don't know what energy is. Richard Feynman said we do not know what energy is. We might know what it does. We can see what it does, right? But what is it? Now, another quote from Richard Feynman is, history is fundamentally irrelevant. Now, this is a physicist talking about physics, right? So when he says the history, as I understand it, the history of physics is fundamentally irrelevant, what is the context of that? What's he talking about? To me, my perception of what he's saying, my interpretation of what he's saying, is that we cannot use what we have learned so far as a way to limit the possibilities of what we can do today and tomorrow. That's the way I understand that. Now, you can understand it your own way, but I have found no way of understanding that to mean that we know everything. Because when someone says something's impossible, that's actually not science. We can look that up on Google. You can say, what is science, right? Does science prove anything? Does science prove something? There's all kinds of articles on science doesn't prove anything. It just documents what we're seeing. So to practice science is not to say, you're breaking the laws of physics. You can't do that. That's impossible. That's not science. Science is what's happening before us and just documenting and sharing that experience. Now, we could say, I've experienced this. If someone else has experienced something else, then we could try to replicate their experience, right? So right now we're going to talk about something that anyone can replicate. All you need is batteries, right? Rick Friedrich uses AA batteries, which are these little size batteries here. See these? You can use little batteries, little nickel metal hydride batteries, right? Now, Rick Friedrich took those batteries and he put like 6 of them in series and 6 of them in parallel, connected the two negatives together of the two sets, and then connected on the positive wire. It's called splitting the positive or loving giving path. Those are both the words he used to describe this process. You put a little light in there. Now we're powering this light at the rate of charging, or we're charging the battery, the batteries in parallel, at the rate of powering that light. So if that light takes, like, let's say the LED light takes, let's say it takes 1 watt to power that. That means we're going to be charging these batteries at the rate of what it takes to run that light bulb. The interesting thing is, I wanted to get a cup. Let me set the phone down for a moment. I'll be back in 30 seconds or so. Okay, I'm back. Just making some space for my science experiment we're gonna do. So we have this cup of water here. This one's empty. okay? And this has water in it. See that water there? It's about right here, okay? Now, this is very interesting. Think about, so we're talking about energy right now, right? If you want to call it free energy, you can call it that. You can call it whatever you want. But really, we're talking about efficiency. What's the more efficient ways of using energy so that we're not drawing more power from the wall, right? How do we minimize the power we take from the wall, right? So we're not straining the grid, right? We don't want to strain the grid, the electrical grid. We want to use as little power as possible. Ideally, we make our own power at home with solar, right? But if we don't own our home, or if we don't have a way of using solar, how can we use batteries, as one example, in an efficient manner? How can we do that, right? So some people call this a gasoline replacement. Some people call it free energy. Some people call it going off the grid. Some people say you can't go off the grid. It's not legal to go off the grid. Well, I'm not going to get into all the details of that, which I don't even know about. All I know is people have solar. They're still connected to the grid, but they have no electric bill, or they have a very small electric bill, or their electric bill is half of what it would be if they didn't have solar. Think about this. I've not heard of one case. Everyone that I've talked to that has solar, okay, I'm talking about California. Everyone that I've talked to, hundreds and hundreds of people, right, over the years. Everyone that has solar, their electric bill is half of what it was before they had solar. So anyone that says, well, I'm going to have to pay all this money for 20 years, and then what am I going to do at the end? Like, what happens then? If you don't get solar, for people that don't get solar, they're paying twice the electric bill, and they have no solar at the end. If you have solar, then you pay half your electric bill, right? Because it cuts your bill in half. Let's say you pay it for 20 years or however many years it is. But at the end, do you own those panels, right? And then you saved all that money. So even if you didn't own the panels, let's say you just saved money, you still saved all that money, right? So somehow people find a way of thinking about solar as it's not good for them. But then I'll talk to someone right across the street or down the street or another block or another city, all those cases where they're like, yeah, it worked for me, but someone else just down the street will say, no, that's not going to work for me. I already made the calculations. So the important thing is to continue to do research and to ask people, ask your neighbors, ask people that are using the technology. That's the important thing to do. Because if you just rely online, what's online, if something's telling you not to do something, if you don't talk to people that are actually using the technology, then I would say the research project is incomplete. This is just how I was taught. I was taught to talk to people that use the technology. Don't just limit yourself to what articles are saying, okay? That's very, very important. Okay, so now we're going to compare right now this water. Let's imagine this water represents the energy in the battery, okay? Now, this is as it applies, I guess we could say, both to a regular battery, using it traditionally, which is where we just have, when I say traditionally, let's say we have one battery, and I'm going to discharge this battery at the rate of powering some load. So let's say I connect a light bulb to it, okay? And you can do these tests. I've done these tests many, many times. Let's say we connect the negative and the positive up to something, and we run that light down, run that battery down. Now, where does that energy go in the light bulb? Do you think the light bulb uses the energy up? Or is the energy moving from one side of the battery to the other side of the battery through the bulb? Is that what's happening? That's my understanding of what's happening. So the energy never leaves the battery. It goes from one side, one pole, to the other. Now, which way it goes, I'm at the moment, I'm not recalling which direction it goes. I always confuse myself with these things. But you can easily find that out. What direction does the electrons flow to, right? If that's what's actually happening. If the electrons are what's moving, where do they go as the battery discharges? And then is recharging the battery, are we adding energy to the battery, or are we moving the electrons back over to the charge side, right? My understanding is that's what we're doing. Now, confirm that for yourself, but my understanding is when we plug a charger in and we charge a battery, we're just moving the energy back over to the other plates, if we say it that way, the other pole. So there's something very interesting that happens when we involve charging batteries with batteries. I'm going to say it that way, okay? Very, very interesting thing. And Rick Friedrich calls it the loving giving path. Now, Rick Friedrich tells people that he's not the first one to do this. In fact, he's just documenting a long history of brilliant scientists and physicists and electrical engineers throughout history doing this. And some of the smartest electrical engineers in the world have experimented with these circuits for a long time. And if you want to get all those names, you can just look up Rick Friedrich on YouTube and look at his research, because he likes to collect information and then bring it all together and make it simple to like access, right? So everything I'm saying like right now about batteries, it does relate to what he's talking about, but it's also taught by many, many people. So if you just look up these circuits, you'll be able to find more about this. But you can start, if you want a starting place, you can start a Rick Friedrich YouTube channel. Loving Giving Path, okay? And he made a video called Simple Free Energy, and it really is simple. I think he has like 4 batteries, and he's showing you this circuit. Now, right now, I'm not going to be connecting the wires and everything. It gets very complicated when there's wires going all over. I'm just going to talk about how I've done this test and what I understand to be happening, okay? Now, I understand a battery discharging itself, right, at the rate of powering some load, whether that be an electric motor. So if I power this electric motor, let's see, I have one right here, but this one's the wrong kind. This one has 3 wires. There's electric motors that have 2 wires on them, like this big one here, this big motor right here. This motor has 2 wires on it. It's a brushed motor, and it has 2 wires coming out. See this? So this is the positive and this is the negative, but if you reverse it, it just turns the motor backwards, right? Now imagine I connect these 2 wires to this battery. This is going to spin, and this is going to discharge, which I understand is the energy is going to move from one side of the battery, from one pole to the other pole. That's my understanding, okay? It's going to go through this motor, and it's going to be just like this water. See this water in this cup? Watch what happens when I pour it to the other cup, right? This cup's empty, right? This cup's completely empty. So we can think of the cup, the 2 cups, as 2 poles, right? Like a positive and a negative. And so this is going to be a full battery right now, okay? It's going to be a full battery, and all the energy, all the electrons are going to be on one side, right? I'm simplifying all this, but you can confirm all this for yourself by researching it. So I'm going to pour the energy. Now imagine when I'm pouring the energy, I'm going to say it that way. I'm pouring the energy from the battery. Now it's going to the other cup, right? See what I just did? I poured it to the other cup. Now imagine that I'm spinning this motor. Let's say this motor had a water wheel on it, right? And the water, as I'm pouring it to this cup, is making this motor turn. Now, in actuality, it would be too difficult to actually do that. But just for simplicity, just for the sake of simplicity, imagine that that's kind of what's happening, right? As the electrons are moving from the battery from one pole to the other, it's making this motor turn. But no energy leaves this battery, right? If that's correct. This is like a thought experiment, because I read a lot, and it's when I try to make sense of things, I'm trying to share with you what I think is correct about what's actually taking place, okay? Because sometimes things are overly simplified, and sometimes things are overly complex. So right now I'm just trying to share what I think is happening with the battery, and what happens when we give the energy from one battery to another battery, as distinguished from a battery using up the energy by itself, right? Because most things like this electric motorcycle has a lot of little batteries in it, but it's all wired to be one big battery, right? So this motorcycle is going to make this motor spin, this big motor this has, right? There's a motor in there, right there with the fins on it to stay cool. This motor is going to discharge itself. I'm sorry, the battery is going to discharge itself on this electric motorcycle at the rate of powering that load. So the energy is going to move from one pole to another, right? But now imagine I have a second battery, another battery, a separate one, right? So that's what we're going to look at here. We're going to imagine having more batteries now. So now for this to work, so these are lead acid batteries. We don't want to do this with lithium, because lithium you can't overcharge it. It's really important, right? But with lead acid is like really robust and durable. You do want to make sure that you're not damaged, like overheating cells, and you got to be safe. You still have to be safe. And I'm not encouraging you to put yourself in danger. Make sure you do any experimentation with someone that knows more than you, okay? I've studied a lot of videos, and that's my experimentation is based on lots of studying and researching. I haven't had any trouble with batteries I haven't had any accidents with the lead acid batteries. These are sealed batteries. Haven't had any trouble with them. And I'm going to tell you the way I did this experiment, okay? So imagine that I'm having these 2 batteries. Let's say we have 4 batteries right now. This is just a real simple experiment. Imagine we have 4 batteries. We have these 2. I'm going to wire these 2 in parallel. Parallel means the negative gets connected to the negative. So the black pole, the black and the black get connected together. And the positive get connected together. Now that just makes a 12-volt battery with twice the capacity, right? Now instead of just, how many amp hours is this? 18 amp hour. So now we have 18 and 18, 36 amp hours at 12 volts because we connected those 2 in parallel. It's called parallel. Now let's imagine that these, let's see how many amp hours these are. Let's see if we can see a number on this one. This says the same thing. It's saying 18 amp hour. Now I don't know if it's 18 amp hour. Is it 18 amp hour? I don't know which one this is because it says there's a 15.3 and an 18. So I don't know how to know. I don't know if it's marked or not. But right now, for the sake of simplicity, we'll just call it that an 18. We'll say it's the same as these. These are 18s. We'll call this an 18. And so now these 2 will get connected in series. What series means is, and this is very important what I explain right now, series is one of the positives connects to one of the negatives. But that doesn't mean we connect the other 2 together. Some people ask me, oh, do we also connect the other positive? No, that's a short, and it's going to throw a big spark, and it can actually burn you and hurt you, okay? You just want to connect one of the positives to one of the negatives, or one of the negatives to one of the positives. Same thing. So in the end, we're going to have one of the batteries with one of the poles open, and the other battery with one of the poles open, okay? So we connect one of the positives to one of the negatives, and then this becomes our output, okay? And we're going to have 24 volts now. It adds the voltage up. Series adds up the voltage, okay? So this is series. It's called series when you put a plus to a minus. And then the outputs are here and here. So if I was going to power a motor, I would connect the motor to the plus and to the minus. And if I reversed the motor connection, that would spin the motor the opposite way. Now, the reason I'm establishing that 2 batteries are in series and 2 are in parallel is just to establish that the voltage for this loving giving path, or splitting the positive, or charging batteries with batteries, okay, this whole idea requires that one set of batteries must be a higher voltage than the other set, okay? And this is why I'm not encouraging anybody to use lithium, because lithium, when we're let's say we're charging this set, right, with this set, this is higher voltage. If this was lithium and you go above the safe limits of the cell, you'll damage the cell, right? The battery could explode, it could overheat and explode, it can have a lot of bad things can happen. So that's why if you're going to do something like that, you're going to have some precautions in place and make sure you do not overcharge those cells. So this would work. It could work with lithium, except never exceed the maximum voltage of the cells. That you'd have to watch that, right? So I'm not even going to talk about lithium because of that, because that you'd have to do that on your own. You'd have to make sure you never go past that voltage. Now these cells, I've had a 12-volt battery up to 16 volts, and some people I've read that have had their lead acid batteries up to 40 volts by doing this kind of experiment, and nothing has the battery didn't get harmed at all. That doesn't mean try to reach 40 volts. It doesn't mean try to do that. It just has happened to some people that have done this for many, many years, where they're sending the charge back and forth, back and forth. And how do you send it back and forth? I'm going to skip ahead a little bit by saying charging batteries with batteries is simply, we have these 2 in series and these 2 in parallel. So this is 12 volts together, and this is 24 volts together. And then we connect the negative of this set of batteries, right? So these 2 negatives are connected together, and then we take this negative and connect it to the negative of this set, right? So if these 2 are connected together, then this one's open. This is my output, right? And this is my output here, because these 2 are connected together to make it series. So this negative is going to go to these negatives, right? It's going to go here, and this is connected to here, right? So we're connecting the negative of one set to another set, and then the positive, this is splitting the positive. The positive goes through our motor, right? So it goes into the positive here, if I recall correctly. But again, if you put it to the negative, that just makes the motor spin backwards, right? So it goes into the positive, and then this wire goes to the positive of this parallel set, right? So you can go to either one because these are connected together. It's called splitting the positive. We're powering this motor with one wire. That's interesting, right? So some people call this one-wire technology. There's other one-wire technologies as well, but this is now some of the words that are used is this is a negative resistance line right here. This is I think what some people refer to as negative energy. Maybe we can use the word negative entropy. I don't know. People get really upset when you say that, though, and I'm not saying I'm correct in using that word. These are just words used, okay? So don't try to use that word against me or your own mind's imagination. What we're trying to do here is think about other ways of wiring a circuit that's more efficient than this just charging a battery upon itself, and then that being the end of it. Then we have to plug it into the wall charger and charge it back up. Instead of that, we can... See, I just got an image when I said that right now. So let's imagine what's happening with the water cups if we're discharging a battery upon itself, right? That would be equivalent to, remember we poured the water from one cup to another, right? Now, to charge a battery, if we're just using one battery, it's not connected to anything else, and we're just plugging this motor directly into the battery, I poured the energy from one cup to another. That's going from one pole to another, right? That's it discharging. No energy left the battery. It just went from one pole to the other, right? And it spun this motor while it did that. Now, what we traditionally do, if I say it that way, is we plug a charger in, and what does the charger do? The charger takes the energy that's in this cup, which is, this cup represents the pole, right? And I'm not sure which pole it is, but that's not hard to figure out. The idea is, what's important is that we know, that we understand in this thought experiment, that the energy is going from one pole to another, and charging the battery is just putting that energy back to the other pole. So plugging a charger in is the equivalent of doing this. The charger is putting the energy back into the other pole, right? Because one cup is a plus and one's a minus, right? One's a plus and one's a minus. And the idea is the charger, when we plug it in, it moves the energy back over to the other side. So that's what that energy is. We're just using energy, external energy, to move that energy back over. But we can use batteries to do the same thing, okay? And just like actually pouring this water back and forth, the same way that we get some evaporation, there is a little bit of losses, very little, each time the water's poured back and forth, just like water evaporates a little bit, right? It's similar to that. So eventually, after sending the energy back and forth, it will require charging, an external charging source or some other charging. It could be solar. The interesting thing is, let's say while we're spinning this motor through the two sets of batteries, right? Let's say this is in series and this is in parallel. The negatives are connected together of the two sets, and the positive from this set goes through the motor and then to this positive, so splitting the positive. While this motor spinning, we could connect a generator to that. So this motor is now spinning, and we can connect the generator to that. And that generator, which can be an alternator or something that produces a charge, right? It can produce voltage and a current. That can help to charge the batteries in parallel. We can use, and so what's happening is when you put a load on this, all it does is charge those faster. It charges the batteries in parallel faster when you put a load on this. So let's say it takes 1 amp to spin this with no load on it. That means those batteries will charge at 1 amp. And those will be discharging at 1 amp, right? Same thing. So those discharge at 1 amp, this charges at 1 amp. Now, if we put a load on this and this is now spinning a generator or an alternator, something that gives us a voltage and a current, my guess would be to charge these up, not those, because batteries don't like to be discharged and charged at the exact same time. You can do it. How do we know? Because our cell phones. What does our cell phones do when we're using them and they're plugged in? Right? Yes, they get a little warm. Some people say that it's like 10 times less efficient to charge a battery that is being used, approximately. I think that's the approximate number. So it's much more efficient to charge a battery that's just being charged. These are already being charged by the circuit we have set up, right? It's already being charged. So I would just add more charge from our alternator or generator going to these. That's the way I would do it right now as a first experiment. And that's the way I've done it when I've done experimenting. I've always charged the ones, I would just added more charge to the ones already being charged, right? Because at first I thought, oh, what if I charge those? Would it just run longer, right? If I just charge those? But that's a higher voltage, and those are being discharged because they're sending their charge over here through at the rate of powering this, right? So as much energy it takes to spin this, these are being charged at that rate. So let's see. Now I was talking a moment ago about using an external charger to fill the cup back up, right? But instead of doing that, let's see what happens when we send the charge from one set of batteries to another, okay? I'm going to make a lot of videos on this, and I'm going to talk about this often because I like thinking about how to understand what I've been studying, if I say it that way. And they say teaching is a great way to learn. So I'm going to make videos where I'm sharing what I'm experiencing and seeing to help myself understand what I'm learning, really. So, and to help myself to better understand what's taking place or what could be taking place. So now if we send the energy, if we just say energy, right, we'll just call it energy. We can call it electrons or energy or charge. Whatever is making this motor turn, that's what we're talking about, right? If we're taking the positive, so the negative this is parallel, these are in parallel, these are in series. So negative to negative, positive to positive, and then here we have positive to negative, so these are in series, and we take this negative and connect it to those two, right, to this negative. I said those two because this negative and this negative are connected together, right? Because this is parallel, 12 volts. These are 24 volts, and our negative is connected over here to this negative, and our positive goes through the motor, right? Now, when we do it this way, this is a very efficient way. This is literally without plugging a charger in to move the energy from one cup to another. Now what we can do, let's say this motor stops spinning. That means these are full, these batteries are full, and these are depleted now, right? Now, we disconnect the batteries. We can disconnect both sets of batteries. We connect these two in parallel. So now the negative is connected to the negative. So we disconnected everything, right? And we connect negative to negative, and then we connect the positive to the positive, right? So now these are 12 volts. And then these two, we connect them in series, so we get 24 volts over here now, right? So these are the charged batteries. These are the depleted batteries. Again, depleted, no energy left the batteries except it moved. Wait, what happens in this? Actually, what is happening in this? I have to tell you, this is interesting. Where's the energy that was in those batteries? Did it go to the other pole? I don't actually know. What I know is, here's what I'm just gonna, all I can do is talk about what I know. I don't know if it went to the other pole or if it went to these batteries, or if it went to these. How did that work? Let me think about this. My guess would be that it went to the other pole, but only after. No, I don't know. I don't even want to guess. I'm just going to state right now that I don't know. I'll tell you right now, I don't know everything that's happening. All I know is that we can keep sending this energy back and forth, back and forth. That's all I know. And maybe you have some ideas about what's happening. But what the important thing is that anybody can do this. So let's say these two are now in parallel. So we have 12 volts here, and these two are in series. So I'm going to connect this positive and this negative together. And then I'm going to connect this negative to this set of batteries that are now in parallel, right? So this negative of the series set of batteries, the negative is going to go to this negative, and then the positive, which is here, right? Because these two are connected together. This is our output wire. Here and here is our output. So this went to that set, and then this one goes through the motor. So this goes to the positive, right? So this positive goes to the positive, and then the negative of the motor goes to the negative of this parallel set. Now we're charging this set of batteries with this set of batteries, okay? These are the fully charged batteries, these are the depleted batteries, and we're going to charge these batteries with this motor, with the energy going through the positive, right? It's called splitting the positive or loving giving path, because when you give the charge to another set of batteries, you can just keep sending it back and forth, right? With some losses, right? Like we talked about evaporation of water, it's similar to that. But people have sent this energy back and forth many, many times. Like imagine sending the energy back and forth 10 times or more, or just keep on sending it. And that's not even with running an alternator or generator on this. If you run an alternator or generator on here and charge up even add more charge to the charging set of batteries, that would probably help with the losses, and you probably could just keep on going, right? And you can see that for yourself. You can find different ways to do that depending on how efficient your generator is. From what I'm learning about generators, I would say you would want the generator spinning extremely fast and have only like 2 magnets passing a coil. Like think of the John Bedini motors. John Bedini wheel or motors where the magnets are spaced out 5 inches apart and the battery charges between the magnets, right? When the magnet passes the coil, it's not when it hits the coil that it charges, it's between the coils. So I would think that pulsing would be a more efficient way to charge this, right? The pulsing of charge, not continuous like this, like spinning this. If we're trying to charge a battery with this, it would be very hard to turn, right? So my understanding is it's more efficient when the magnets are spaced out at least 5 inches. That's an approximation. And you can also just do it with 1 magnet or 2 magnets, like 180 degrees out of away from each other. And that can be 2 norths, like John Bedini used all north poles. But it could be north, south, north, south. It could be north, 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 north. So, and that means facing the coils, right? So if we're sending the energy in this manner, right? So now these are in series, or what's in series now? Yeah, these are in series and these are in parallel. And the positive goes through this motor and then back to this set. And then this motor will spin until these batteries are full and these are depleted. And then we can just keep going back and forth. And what we're doing when we're doing that is we're just doing this. We're pouring that energy. We're pouring that energy back and forth, right? We're pouring the energy back and forth between the 2 sets of batteries. And we're not having to charge with plugging into the wall, right? We don't have to use the plug, right? We're not having to plug in the charger to move that energy from one pole to the other, but rather we're using batteries to move the energy from one pole to the other, if I say it that way. I think that's the way to explain it, to understand it, and to think about it. But this is a work in progress. It's a thought experiment, and all I know is it works, but what's actually happening, that's the fun part to think about. Now, some people want to think about no such thing as free energy. I wish there was, like people would say, oh, I wish there was, but there isn't any, so give it up. Now, if that's what excites people to be in that space, that's not interesting to me. What's interesting to me is when I was born and able to talk, before I could talk, I was wondering what energy was, what makes a light bulb turn on, what makes the sun work, what lights the stars, what energizes us, in addition to the food we eat, what else is sustaining our cells, right? What's sustaining the atoms and the molecules and the cells, not just the food we eat, right? What sustains the universe? What's the difference between the electrons that make up this everything we see in front of us and the electrons that make up me, right? So this is the kind of things I thought about, and it is true that my parents tried to get me put on medication because I was asking too many questions, but luckily the doctor said, you have a brilliant young man here, and I was very little. It's before I started school, and there's not anything wrong with him, but did offer to put my parents on medication because they were obviously getting anxious about my intelligence. So I was lucky to have spoken with such an intelligent doctor, because some doctors, I don't want to put doctors down, but some doctors were quick to put children on medication, which I think is less popular now. I don't know, I haven't followed that. But I have read in the past there was a time period that medication, like kids seemed to be getting over-medicated with just even if they were just, very excited about life and excited about things. But I don't know. I wasn't there. I don't know the kids. I'm not a doctor, so I can't give medical advice. But I'm just telling you that in my experience right here with batteries and my understanding, this is you could call this free energy, and you could have. One of the things that happens is there's many different things that could be used here in place of a motor. Some people will use heaters, right? So if they need heat, they can run a heater like this, right? And that can help keep you warm, and you can keep running the energy back and forth, back and forth. And on the charging side, and also there can be a lot more batteries being used, right? This can be a large battery bank, and this can be a large battery bank, right? But you'd have to choose and decide on how high a voltage you want on the charging side, and how high of a voltage you have on the series side, if we say it that way, the side where the voltage is higher. I think that all comes with experimentation, right? So on this side, on series, if we had like let's say we had 300 volts worth of batteries all wired in series, and on this side, what would you want the voltage at? Would you want it at like 150 volts, right? So series, like maybe have some in series and some in parallel, or would you have them all at 12 volts? Would you still have them there? So there's a big difference in voltage. And then running that, running the negative wire from one set to the other, and then the positive going through your heater, through your water fuel cell, your hydrogen water fuel cell, right? Imagine running a water fuel cell. Does that work? I've done some experimenting with that, but think about that if that worked. Think about if there was a way to make that work. Or even if making that work means you're running a generator or a motor, right? You're running a motor through the two sets of batteries, but this is powering like an alternator, right? So an alternator is connected to this, and that alternator is running a water fuel cell, right? And that water fuel cell is helping to run a generator. I'm just throwing some ideas out there. See, what I wanted to originally do was do all these experiments and make videos of it and talk about it, but what I found is with so many things happening all the time in life, I'm always taking on new projects. The old projects, I still get to them, but I'm just like always doing new research, and there's always new things coming. So what I'm going to start doing is just making videos. I might just make videos that repeat what I'm talking about today in different ways. And it's going to be less about me having a working experiment in front of me, which I will still do. I'll still do some of that, but it's going to mainly be talking about the theory of what I am thinking about between what takes place between two sets of batteries when you give the charge from one set to another set. Because this is not something that is, I don't know if it's talked about much. I think people are thinking about it a lot. I think people experiment with it a lot. I don't know how much, I want to say like how certain anyone is of what's actually taking place. But what I'm telling you is in a simple way, if we just think of pouring this water back and forth, right, without plugging a charger in, without having to plug in a charger, right? So if my hand pouring this water back and forth represents a charger, or my hand represents just rewiring these two sets of batteries, series, parallel, and then parallel, series, or no, series, parallel, and then series, parallel, and then series, parallel, and then series, parallel, going back and forth. What allows it to move is the voltage being higher on one side. That's what allows that to work. That's what allows this to do work, when the voltage is higher. And that higher voltage is the same thing as being able to move that energy from one cup to another, right? Or move that charge from one side of the battery to the other. It is interesting to think about. Where I kind of got stuck earlier was if these batteries are in series and I have the negative of this set connected to the negative of that set, then is the energy still going from one pole in this set to the other pole in this set, right? I don't actually know. I mean, I might actually have said the answer in talking to you in this video and just not realized it yet, because that happens a lot. I'll watch old videos and say, oh, I didn't even know that I said that, and the answer's right there. I said the answer and didn't really understand that I said something, meaning that I was aware of something or memorized something that I didn't realize yet. Like, I just didn't realize it. Anyway, this is a very efficient way to run a bicycle, to run, some people run their houses like this. That can be done, and they use so many different ways of using their generator and alternator system, right? You could have like this could be a big motor, and then it could be spinning like, multiple alternators or generators, and that could be helping to charge the batteries that are being charged. And then do you set the system up so that it flips itself from series to parallel, series, parallel, series, parallel, that it can just do that itself automatically and just keep the energy moving back and forth, right? And then can you add solar and wind to that as well? So the batteries that are being charged, the battery bank that's being charged is, it just helps adding, it's adding more energy to that system, right? Anyway, everyone, True Zero Emission signing off. It's a 40-minute video, 39 minutes and 7 seconds so far. And I just wanted to share my thoughts with you, and I'll make more videos like this. That's what I plan to do. And I have no idea what I'm going to call this video, but we might just call it what Rick Friedrich called it, which is simple free energy. Have a good day, everyone. See you next time. Bye.